Okay, this podcast I'm going to do is dealing with section 8.8 in our textbook on the area of a circle. I'm not going to, in this one, I'm not really going to go over what the area of a circle is. It's formally you guys have probably seen before in the past, area equals pi r squared. The part that I want to cover is the thing that deals with probability in an area. These are the type of problems that give people headaches. Now, when you're talking about probability in an area, usually the first thing that pops in your or first kind of question that you actually see is dealing with dartboards. So I constructed a dartboard here that's got 4 circles. And usually one of the questions you're asked is, okay, what's the probability of us getting a bullseye? Now what we're assuming when we say we're getting a probability of bullseye, if I throw a dart, it's going to land somewhere in this dartboard. I'm going to assume I'm that good and that it's not going to be in this white area. Okay, now if I go with that assumption that it's going to land in that dartboard, the way to figure out your probability of landing the bullseye is we take the area of this bullseye and divide it by the area of the whole dartboard. Okay, and the way I made this dartboard, the radius of this inner circle is r. The radius from this center point to this second circle is 2r. To the third circle is 3r, and to the fourth circle is 4r. Okay, if we go with that assumption here, the way we figure out the probability of getting a bullseye is we have to figure out the area of the big circle, and again, area equals pi r squared. The radius of my big circle is 4r long. So what I want to do is I want to square that 4r, and that'll give me 16r squared. So my area of my big circle is 16 pi r squared. Okay, so, and the way you'll usually see with these probability questions, you'll see like a p and in parentheses something that's asking what the probability of getting that thing in parentheses is. So my probability of getting a bullseye is the area of the bullseye circle divided by the area of the big circle. Okay, area of the bullseye circle is just pi r squared because the radius was r. The area of the big circle is 16 pi r squared. So when I divide the two, what's going to end up happening is I got a pi r squared on the top and a pi r squared on the bottom. They're going to cancel out, and I'm going to get 1/16 as my probability, which is 0.0625 or 6.25%. Okay, now that one isn't too bad. But what happens if I ask you to find the probability of it just getting into one of these rings? It's like maybe this outermost yellow ring. Well, the way you figure out that is it's the same process. I need to know the area of that ring, and I divide it by the area of the whole thing. Now, areas of the rings are a little bit more complicated, but what we have to do, say if I wanted to get the area of this outside ring, the way to get it is you take the area of the outside circle, and then what you do, you subtract the inside circle from it. It's like I'm making a donut. I got this little cookie cutter, and I'm going to cut this inside portion out, and I want to know how much I'm going to cut out of the big circle. Okay, and that's what I did here. So my probability of landing in that yellow ring is the area of the yellow ring divided by the area of the big circle. Okay, but first we have to get the area of the yellow ring. So to get the area of the yellow ring, we take the area of the outside circle and minus the area of the inside circle. Well, thankfully we already figured out the area of the outside circle. That was 16 pi r squared. Now the area of the inside circle, from here to this where I have labeled point C here, this radius is 3r, so when I square that I get 9r squared. So the area of this circle from the center to that point is 9 pi r squared, so I'm cutting a chunk that's 9 pi r squared out of a circle that's 16 pi r squared. So what I'm left with is what I got right here, 7 pi r squared. Okay, so the probability of getting in the yellow ring is that 7 pi r squared divided by the area of the whole region, which is 16 pi r squared, which is 7/16, or 0.4375 or 43.75%. Okay, and that's basically how you handle all these probability and area regions. What you need to do is you got to somehow find the area of the region that whatever, say it's a dartboard or a dart or whatever you're trying to throw in there. You need to find the area of that region. You divide it by the area of the whole entire thing. That'll tell you what the probability of it landing in that specific region is.